Okay, welcome to today's class. Topic of today's course is LAN security. LAN security, a part of my CCNA security. Okay, topical LAN security, a part of CCNA security. Okay, self-introduction. LAN, my LAN, current main node. My child is LAN, 现任明教教主。Okay. My CCIE number 13778, security and data center CCIE. My CCIE students have 1,000 plus security CCIE, 200 data center CCIE, Asia's first data center CCIE, 15 years of teaching experience, Master of Security, Wireless, Data Center, and Python, founder of QI Tang CCIE HCIE Lab. For more information, visit my official site www.qytang.com. Author of the book Cisco IPsec VPN. Okay, you can find in Jingdong www.jd.com. Okay, self-intro finished. Let me start. Voice okay? Heard my voice? Let me start. Today topic of LAN security. Two main section. Section 1, MAC flood and MAC spoof. MAC flood and MAC spoof. Every section have 3 little parts. First one, I will teach you the protocol, how to work. The first one, part 1, switch how to work. First, protocol, how to work. The second, attack, hacker attack. Hacker make, MAC flood and spoof. The last one, stop, prevent the attack. Use Cisco security feature, port security, Cisco switch security feature to prevent MAC flood and MAC spoof. Okay. The section 2, ARP spoof. The first, ARP how to work. ARP is a protocol, and I will tell you how to work protocol. The second, hacker attack. ARP spoof, hacker attack. Poise the ARP cache, capture all the packet. Okay. The last one, Cisco security feature to prevent the ARP spoof. The feature name is dynamic ARP inspection, DAI, Cisco security feature to prevent ARP spoof. Name is DAI. Okay. Let me start. The first one, switch how to work. First, I will tell you the protocol how to work, and hacker how to attack, and use the Cisco feature to prevent the attack. Okay. The first, protocol, switch how to work. All has 8 steps. The first step, how to work, switch how to work. Step 1, the 3 computer just power up, just connect to the switch. PC A, B, C. A connect port 1, B connect port 2, C connect port 3. Okay? PCA, MAC, IP is IPA, MAC is MAC-A, and so on. PCB, IPB, MAC-B. Okay? The first thing, PCA want to pin or telnet or SSH to access the PCB. PCB is, for example, is a server, is a SSH server or telnet server. A telnet server is a router. Okay. PCB want to access the PCB, want to pin or telnet or SSH. The first, the PCA check the routing table. Routing table. Okay. PCB check the routing table. He found the PCB is a direct route, connect subnet. Okay. If the destination PC is in connect subnet, the ARP request will request the real PC's MAC address. Is connect request the real PC IP according to the MAC address. Okay. If the host is another subnet, he will request the subnet gateway. Okay. PCA find the PCB is a connector. He send the ARP request package. The request PCB's MAC to IPB. Okay. Request the PCB's MAC. The ARP request package type is broadcast. The layer 2 broadcast. The Ethernet destination address is F. Okay. The layer 2 broadcast. The Ethernet destination MAC address is OF. Okay. Broadcast, layer 2 broadcast, ARP request, A send the ARP request. Okay. The first switch received the ARP request sent by PCA. The switch first received, okay, not the B or C. Switch first received the request. The switch look at the packet source MAC address, learn and update his MAC address table. Okay, receive the packet, look at the source MAC address, and update his MAC address table like below. Show MAC address table, the VLAN 1, the default VLAN, or PC in the VLAN 1, default VLAN 1. The MAC A is connect 0/1 interface. Okay, MAC address table. Then the ARP request is a layer 2 broadcast. The switch will send the ARP request, flood the ARP request to the all ports in the same broadcast domain, except the received interface FA 0/1. Okay, flood layer 2 broadcast, flood all ports in the same broadcast domain except the received one, FA 0/1. PCB and C all will receive the ARP request. PCB and C received ARP request from A. Firstly, update the local cache and then send ARP reply. First, update self local ARP cache and then send a reply. Okay? But if PCC update ARP cache, if update, depend on it has PCA ARP cache before. Okay? Look at the note. Look at the note. Wait. This is PCA, PCB, PCC. C receives the ARP request. Okay, if C has ARP cache for A, IP A mapping IP X, if has ARP cache for IPA, okay, if has. So C receives the ARP request, they will update the ARP cache to IP A to mark A. Oh, if has the ARP cache for A, he will update. If he has not any ARP cache for A, cannot update that. Okay. So B or C update the ARP cache local computer like this. ARP A, IPA, mark A. Okay. Firstly, update local ARP cache and send ARP reply. So B receive ARP request. B has a ARP mapping. Okay. One is change. A request, B reply. A has a B ARP mapping. B has A ARP mapping. One is change. Two has ARP mapping, ARP cache. Okay. One if change. ARP request, ARP reply. Two computer, A and B has ARP mapping. Okay. Not two exchange. Not two exchange. Not A request B, B reply. B request A reply. Not two exchange. Only one exchange. A and B has ARP mapping each other. Okay. B update his ARP cache. B send ARP reply. The ARP reply is the answer. The answer is IPB mapping mark B. The ARP reply is unicast. Layer 2 unicast. The layer 2 Ethernet source MAC address is B. Destination MAC address is A. Okay. Let me look at the real packet. Real packet. We will look at the ARP request and the ARP reply. Okay. ARP ARP first. AB got ARP catch, ARP mapping, then the pin unicast. Okay, this is the ARP request like this. ARP request layer 2 broadcast. Let me look at the packet. Real capture packet. ARP request. Source mark. Source mark. This serial A. Destination MAC address. Layer 2 broadcast. OF. Protocol type. ARP protocol type. OX0806. Okay. Long IP packet. Long IP packet. Option code 1 ARP request. Sender IP address, sender MAC address, request target IP address. This is a question. I have no MAC address. This is a question. Layer 2 broadcast. ARP request flood all ports in the same broadcast domain except received port. Okay. Let me look at ARP reply. ARP reply. Reply. Layer 2 unicast. The source B. The destination A. Non-IP. Okay. The source IP address. The source MAC address. This source MAC address is the answer. You request my IP mapping address, MAC address. This is a request answer. Source hardware address is the ARP request answer. Okay. ARP reply. Layer 2 unicast. Layer 2 unicast. The ARP reply received by switch firstly. The switch update his MAC address table like low. Have two entries. The first one is A, received A request and update. The second one is B, received B reply and update. Okay, two MAC address table. VLAN, MAC, port, mapping. This is a database. Okay, MAC address table is a database. Mapping, VLAN, MAC, and ports. Okay, two entry A and B. A connect to 0/1 interface. B connect 0/2 interface. Okay. ARP reply is unicast. Unicast look at check the switch MAC address table. Find the destination MAC A is connect 0/1. So the ARP reply only send out FA 0/1. Okay, unicast check CAN table, MAC address table, find destination MAC address is connected to 0/1. The ARP reply only send out 0/1. Okay, so PCB cannot receive the ARP reply. Okay, not flood, only send out 0/1. The A received the ARP reply like this. Okay, look at the source source address, IP address, look at the source MAC address, and update his ARP cache like below. IPB, MAC B, okay, ARP cache. ARP cache look like this. ARP, this is a IP and MAC mapping. Okay. Result of the ARP request exchange. Result of the ARP exchange. Let me look at A has B. One ARP exchange. Okay, one ARP exchange. ARP request, ARP reply. One exchange. Two packet. This is the result. A has B ARP mapping. B has A ARP mapping. Switch has two computer MAC address table. MAC address table. Switch had no any ARP cache entry for A or B. Okay. The result. A has B ARP cache. B has A ARP cache. Okay. Switch has two MAC address table entry. No switch had no any ARP cache entry. Okay. This is the ARP exchange result. The communication between A and B is unicast. Only exchange between FA0/1 and FA0/2. Only two interface exchange the communication packet between A and B. So now C open a packet capture app. For example, Warshak. He will capture cannot capture any packet A and B. Okay, cannot capture any unicast packet between A and B. Okay, so switch prevent the network sniffer effectively. Okay, switch prevent network sniffer. This is part one. Part one, switch how to work. This is a normal means, but the hacker has a senior means. So let me look at the part two. Hacker, how to attack and capture the packet in the switch scenario. Okay. Let me look at the part two. I stop the